Hello. Today I'm going to explain section 5.3 homework problems of Pearson calculus. Okay, so first one, number one. We write the following limit into a definite integral. So first of all, when you have an interval a through b, and you have some kind of partition p, if the norm of the partition, remember that the norm is the largest interval, subinterval in the given interval of sigma k is 1 through n of f of k, f of basically xk, or ck in this case, where ck is the x coordinate, like x c1, c2, c3 in the partition, multiplied by the length of each subinterval, which is denoted by delta of xk. Okay, when you have something like this form, if the limit exists, this is becoming the definite integral of the interval a through b function f of x and dx. How are we going to apply this one? For this problem, we have some kind of partition P in the interval of 7 through 16. This part is some number, the number here, these numbers, is cubed and multiplied by delta xk, which is length here, okay? So this is basically the length times width. This showing the rectangle, some of the rectangles. And when you're gonna take a limit that the norm is getting close to 0, basically all the rectangle have like infinitesimally small width. So you have infinitely many rectangles. Well, in short, this will become something like this. So summation sigma is becoming like integral, where the interval in this case is 7 through 16. And this is gonna be basically x cubed. And this is gonna become the delta x, dx, okay? And you don't need to solve this one. So just rewriting, that's done. Okay, next one, number 2. So you have a same format here. The only difference will be inside. This is gonna be something square minus 4 times something of delta xk over the interval of negative 4 through 13. So it's gonna be definite integral of negative 4 through 13 of this one, replacing ck into x. So x squared minus 4x, and replace delta xk to dx. Number 3 gonna be similar. So again, you have norm is approaching 0 of sigma k is equal to 1 through n of 1 over 1 minus ck. That's the main part of the function, and multiplied by delta xk. So again, this is gonna be, in this case, interval is 0 through 4, 2 through 4, and 1 over 1 minus x, ck replaced by x, and the delta xk replaced by dx. Okay, now some property of the definite integral. Suppose we have a function, definite integral from 2 through 3 is 8. What can we say about the following? Number 1. Well, if x is replaced by something, for example, u, then this is basically same thing as fx of integral of fx from 2 through 3. It's going to be same thing. We're just replacing a letter here. Doesn't change the result. So this is going to be 8. Part B. In general, when you have some kind of number multiplied by function for u through v, for example, this is same thing as the definite integral of fx from u through v multiplied by some number b. In this case, you have a square root of 7 times a function and with the same interval. So the product of the scalar number can be put out here. And this part is 8. So it's going to be 8 square root of 7. Next, here is a property. When you have some integral a through b, you can flip up number, top number, and bottom number like this. But when you do this, the result is going to be negative from the original expression. So when you have 3 through 2 of the same function, you can rewrite this one as 2 through 3, but you have to multiply it by -1. Since this becomes 8, so the answer is -8. Part D is basically you want to use the same rule that we used for part B, where when you have some number here, you can just put it in front of this integral. So in this case, the number is, instead of square root of 7, it is -1. Okay, so you can put -1 in front of the integrand, and it's going to be -8. Okay, number 5. Number 5 is you are given that the function, you have a function that the definite integral of 1 through 5 is the area of 4, whereas 1 through 6 is area of 9, okay? So the total area is 9, and here is 4, so this should be 5. Well, that's the intuition, and it is true in general that when you have an integral of a through b of the function plus b through c of the function, then you will get a through c, integral of the same function a through 3. Okay. So because this is equal to 4, 5 to 6, we don't know yet, but the sum is by this rule. This is same thing as 1 through 6. So that's going to be 9, okay? So this is equal to 4. This is we don't know, and this is equal to 9. So we know that this is equal to 5, okay? So that answers part A. And this is like a top and bottom flipped. So by using this part here, same rule applies to get the -5. Okay, next problem. Graph the integrand and use area to evaluate a definite integral. So this is just applying the idea of the simple geometric area. Let's say you have a function y is equal to x over 2 plus 6. When x is equal to -4, the y value is 4. When x is equal to 6, y value is 9. And it is a straight line, it's a linear function. And this expression indicates the area under the curve. So it is a trapezoid. We want to find the area of the trapezoid. So this expression means the area of this trapezoid. This trapezoid has an upper base of 4, lower base of 9, and the height is 10. So it is equal to upper base plus lower base times the height divided by 2. So it's going to be 65. Okay. Now, next one is a bit harder, square root of something. You cannot graph square root of something in general, but when you have y is equal to square root of some number square minus x square, this indicates the upper semicircle of radius r with the center is the origin. So this expression says find the area under the curve where the curve is basically a semicircle of radius 10. Okay, and you want to find the area under the curve from x is negative 10 through 10. So it is basically area of the semicircle itself. So to find the area, so pi times radius square and divided by 2, that's going to give us the area. And because radius is 10, it's going to be 50 pi. Now, next one, the graphing is simple. It's a V-shaped graph. Negative 5 through 2 of 2x absolute value dx. Now, the graph of y is equal to absolute value of 2x is a V-shape like this. And we are interested in the area under the curve or line from x is equal to negative 5 to x is equal to 2. Now, the area under the curve is basically a sum of two right triangles. This triangle have a base length of 5 and the height is 10. And this one have a base length of 2 and the height is 4. So the area is going to be 10 times 5 divided by 2 plus 2 times 4 divided by 2. So that's going to be 25 plus 4, which is 29. Okay. Okay, now you are going to use a formula here to evaluate the integral. So although it is telling you the formula, we can integrate this one by ourselves. So the antiderivative of x is 1/2 x squared. Okay. And from here, you want to plug in the upper number minus input the lower number. That is equal to 1. Okay. Now, next one is basically you need to evaluate this integral again. Well, since this is a linear function, you can find the area under the curve or line by using a trapezoid as we did it before. But let's take an integral. Integration of this, finding antiderivative, it's going to be 40 squared minus t. And you plug in 9 and 6. When you plug in 9, it's going to be 324 minus 9. And when you plug in 6, it's going to be 144 minus 6. So that is equal to 180 minus 3. So it's going to be 177. Okay, next one. Number 11. Use a definite integral to find the area of the region between given curve and x-axis on the interval 0 through b. So you have y is equal to 4x squared quadratic function. So it's a parabola with a vertex at origin. And the interval is 0 through b, and yeah, b must be positive. So we want to find area under the curve and the x-axis. So this is equal to, as the area is equal to integration of 4x squared, where x is from 0 through b. Finding antiderivative, it's going to be 4/3 x cubed. And plug in b first, and you plug in 0 next, and you subtract it. So the answer is 4b cubed over 3. Okay, now problem is graph this one on the interval of 0 through 1 and find the average value. Okay, so let's find area. First of all, the graph of negative 3x squared minus 1 is a parabola with the vertex is at the 0, negative 1, and it looks like this. And we are interested in the interval of 0 through 1. Now to find the average value is basically the integral. You want to take an integral over the interval and divide it by the length of the interval. In this case, length of the interval is 1. So after taking the integral, you want to get this, and you plug in 0 and plug in 1 first. So it's going to be -1, and you plug in 0. So the average value will be -2. Okay, again, now the problem is asking for finding the average value. So average value is the integral of the function between 0 through 15 and divided by the length of the interval. The length of the interval is 15 minus 0, which is 15. So forget about 1/15 for the moment. Take an integral. The antiderivative is going to be 1/3 times t minus 8 cubed. And you plug in 0 and 15. So 1/3 you can put it out. So it's going to be 1/45. Plug in 15, you want to get 7 cubed. Plug in 0, you want to get -8 cubed, and you want to take a difference. Okay, top number plug in minus bottom number plug in. So that is equal to 343 plus 512. So it's going to be 855 divided by 45, which reduced to 19. It's going to be reduced to 19. Okay. Bit complicated one. Number 14. Find, this is a review problem. This is from chapter 4, section 8. So this is just a review, but let's do it. So this is kind of complicated, but the bottom is a monomial. So you can just divide the expression into 2 fractions. We write this into power. This is going to be 5/7 plus 1. So t times t to the 5/7. And this is going to be same thing as t to the power of 2/3. So after reducing this one, this is going to become t to the -2/7. And this is going to be t to the -4/3. Using a power rule, raise the power by 1, and you multiply it by its reciprocal. Do the same thing for here. Raise the power by 1 and multiply it by its reciprocal. Okay, and don't forget to add positive c. Oops, I should have negative here. Okay, -3. Okay. Yeah, that's it. Okay, another review problem from section 4.8. Number 15. R dash dr d theta is equal to negative pi cosine pi theta. With the initial condition, the radius is 3 when theta is 0. So first of all, let's find the antiderivative of this one. And that's going to be negative sine pi theta plus some kind of constant. Okay. Using this initial condition, sine of 0 is 0. So it's going to be negative 0 plus c, and that is equal to 3. So the integral constant must be c. So the conclusion is the radius function is negative sine pi theta plus 3. Okay, what values of a and b maximize the value of the function? Well, I have to assume that a is less than b. Okay, now this one is basically showing the area under the curve. And this function is a parabola with upside down parabola. And when you factor it, you want to see that the x-intercept is 0 and 1. So the graph looks like this. And you see that when you try to find areas, remember that the area under the x-axis is going to be counted as negatives. And the one above is going to be counted as positive. So to find the maximum possible value of this, we just want to count the positive part. We don't want to include any negative part. So the best choice for the integrand is on the interval of 0 through 1. That's going to be the best we can do. We have to assume this one because if a can be larger, then we can include, like, for example, minus 10 through 0, which is very small because it's negative value. So this is a very small number. It's a negative number. But if a and b is flipped, so for example, integrating from 0 through negative 10, then this part is going to be counted as positive number. So it's going to be very, very big number. So this problem doesn't state it clearly, but we should assume that b is greater than a in this section. Okay. Now use the max-min inequality to find upper and lower bound for the value of this integral. We don't know exactly what this graph looks like. However, we know something about this in the interval of 0 through 1. This function has a value of 1 when x is equal to 0. And when x is equal to 1, it's going to be 1/2. And as x is getting larger, the denominator is getting larger. So basically, this is a decreasing function in the interval of 0 through 1. So we want to know what is the area under the curve. It's not a line here. So this is not a line. It is actually some kind of curve. So we don't know exactly how we find the area yet. But we can say the highest value, maximum value in this interval is 1. Okay. So if this is certainly smaller than the integral of the function that is always equal to 1. Okay. At the same time, the smallest height of this function in between 0 through 1 is this point. So when you compare this integral with this red part, it must be greater than that. So the 1/2 function between 0 through 1 must be smaller than or equal to the area under the curve. Now this is obviously 1/2 times 1. This is 1/2. And the blue area blue area is going to be 1 times 1, which is 1. So this answer is somewhere between 1/2 and 1. Okay. Okay, show that the value of the sine of x squared over 0 through 1 cannot become 2. Well, we don't know how to integrate this one. We don't know how to find antiderivative of this one, but we can say something about this. Notice that the sine of whatever is always less than or equal to 1. Okay. So we are sure that in this interval, well, this is certainly 0 when x is 0, but no matter what is x is, it is always less than or equal to this one. Okay, so using the inequality, this function is always less than or equal to 1. Okay, and that is the integral of 1 is equal to just 1. Okay, so this function is, this integral is less than or equal to 1, which is clearly less than 2. So that explains why the integral cannot have a value greater than 1 or equal to 2, and that's the choice A. Okay, now this one is another sine function. So use the inequality, sine x is less than equal to x for x is greater than 0. So this is giving fact that y is equal to x is always greater than or equal to sine x when x is greater than 0. Okay, so that means that is also true in the interval of 0 through 1. So here's sine, and here's y is equal to x. So area under the curve, area under the line between 0 through 1 is greater than or equal to area under the sine function. And since area under the curve, area under the line is basically the right isosceles triangle, which is should be 1/2. So the integral of sine function between 0 through 1 is also less than or equal to 1/2. So that could be considered as upper bound. Well, the last two questions basically just use some calculator to draw the rectangles, but it's not, you can kind of see it. Well, so you have 1 minus x, y is equal to 1 minus x, and you want to take a Riemann sum for the interval of 0 through 1, because the problem is saying 0 through 1, okay? So we want to estimate the area under the curve by using rectangles. When you use 4 rectangles, you split into 4 subintervals of the same length here. And problem is which height we should take, which height you should take. And I'm not sure what is a cast does. I'm not sure whether it's going to be using the midpoint rule or left point or right point. But looking at the choices, the one that is consistent using a consistent rule is B only. B is clearly using the left point to estimate. It is using a left point. But choice A, we don't know which point they are using. And choice C also, we don't know which points they are using. Like choice C is using like left end for the first 2 rectangles, but the right end for the other 2 rectangles. So it's really not consistent. The same thing could be said for the case when you have 10 rectangles. Looking for the consistency, you see this is like a left, 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 but next is bottom, right, 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 right. And this one is like a right, left, right, left, right, left. It really doesn't make much sense. So this is the only consistent one, and it is using a left end point for the estimation. Okay, this is kind of harder to see, but the problem is the same. You want to take four, um, four rectangles between 0 through pi over 2. So the sine function is something like this, where here's pi and here's negative phi. We are only interested in the interval 0 through pi half, so we want to estimate the area here. And again, the system is probably using the left-hand point, so try to see which one is using the left-hand point. Okay. So here is pi over 2. And when you use the left-hand point, the first rectangle has no height. Second one is this. Third one is this. And fourth one is this. All inside. All inside. And you only can see visible rectangles. There are only 3 of them. So A is the best choice. Yeah. B has more than 4 rectangles. And C has left, 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 but it's missing the first part. So it's kind of strange here. Do the same for part B. It's very small to see, so you can just click this one to enlarge. And well, this is not really estimation. This is like a perfect area, and that's not what this problem is asking for. It's not really rectangle at all. Okay, this one, it's not really, it is using left end, left end, left end, left end, left end, so it looks good, but it doesn't use 10 rectangles. And this one, left end, left end, left end, left end, and 5 blue, and 4 gray, and 1 invisible rectangle at the first. So this has 10 rectangles, so this is the best choice. Okay. So that's all for section 5.3.